So Nick, how does signal design, curation, and refinement differ in Kubernetes environments?
Yeah. I think the heart of this is that the threat model needs to be container centric. Your first stop when thinking about your detection and response strategy for Kubernetes containerized environment should be the Mitre ATT&CK framework. Honestly, that should be your first stop. You should reason from what you want to actually detect as part of your control framework, and then implement technical mechanisms to do so, right? Work backwards from what's available. That's my strong advice. Now you ask yourself, okay, I've threat modeled the environment. The MITRE container attack framework is 30 some controls, starting from initial access to lateral movement, to pivot, to persistence. We've all read about this. We know what MITRE is about. But pick a number that you can start with having coverage for in a period of time. Like, let's say you're early in your journey. Pick the top 3 or top 5 attack framework recommendations, and then build the mechanisms to actually detect and actually respond to them. Like, seriously, like, start small and be intentional. And then over time, curate and improve those. And what you'll see is you're actually finding things that are happening that you would have probably never had visibility to. Now, you need a mechanism to often fire alerts at that low level of observability, the context that we talk about. However, it's possible to do that. It's just a matter of having the tooling in place to do so, and being insensible and intentional about where you focus your attention, because you cannot boil the ocean, right? There's a lot of work that needs to go into implementing this intentionally. And any vendor tells you, I'll handle all of the MITRE ATT&CK framework for you, that's a fool's errand. That's probably not going to be the case. You're going to need to be intentional and prioritize which ones you have coverage for.
Yeah, it's like if you have an alert across all the MITRE attack framework and the alerts are all fake, and marketing can say I have 100% MITRE ATT&CK coverage, but the reality is 95% of them need to be tuned and refined because your environment is very different than whatever they built their default signal for. And everything ends up being a false positive. Yeah, it's not true. So anytime you see 100% MITRE ATT&CK coverage, it's fake. Anytime you see 100% anything, just know that's marketing. That's marketing. Anytime you see like a curve that goes, not a curve, but a linear line, that's called marketing as well. Okay, actually, we got a question, which is, in the context of Kubernetes security, should companies prioritize SPM, security posture management, or runtime security? Sandeep?
Both. It's not this or that. It's not optional. You need to do both, and really ensure that you have these checks and balances, as we mentioned earlier, in place as part of posture management, as part of various scanning that you do, configuration checks, and absolutely runtime as well, because that's where you're going to get that packet accurate or syscall accurate detection and response that you need to ensure that you're truly protected. So you need both.
Yeah. I think my take here is slightly different. I do think the CSPM is more table stakes and it's more foundational. If you don't have that, but you have runtime, you're probably going to miss a whole category of control. And like generally, the maturity curve follows the following paths. CSPM or CSPM-like capabilities usually come first in terms of absolute priority, which I think is your question. And then secondly, runtime monitoring.
We got one more question, and then I want to leave everyone with one piece of advice. So the last question we got is, what role does eBPF play in Kubernetes detection and response? And for anyone who don't know, eBPF stands for Extended Berkeley Packet Filter.
Absolutely. Nick, you want to take this one?
Yeah, sure. So this is really one of the predominant technologies that allows a product like Threat Mapper to intercept calls to the kernel, so it's calls to the kernel, and capture the context of that call into a format that is eBPF, and then send it to an analytics engine that can then provide you an overlay of that specific context for that specific call, and provide an output of this is what's happening. So because it is so low level, I think the best like actual analogy that you can think of, it is similar to how antivirus or anti-malware tools work on any modern system. All of these tools, they intercept calls to the kernel and they observe them and they introspect them and then they provide a context. In the example of anti-malware, antivirus tools, they're blocking often, or they can be. In the context of eBPF, they're usually observational, but they can be blocking. Sandeep, if you want to add anything more to that.
Yeah, absolutely. I think, I have a pretty strong opinion on this, Nicodemus. I think any meaningful technology, any meaningful security, observability, tracing, analytics, what you name it, any of these technologies that you need to collect deeper telemetry will be and should be built on top of eBPF when it comes to cloud environments, really, right? Especially Kubernetes, more so. So absolutely, eBPF is your friend for runtime, deeper telemetry, deeper context, you name it. We rely on it significantly for pretty much everything that we do. There are some cases where you do not have host access, where eBPF doesn't work. For example, some of the Kubernetes platforms. So you don't have eBPF there, but you can always fall back to other slower tracing mechanisms. For example, in Fargate there is no eBPF access as yet, but you can always fall back to FS Notify essentially, right? To be able to trace file system operations or stuff like that. So my answer is absolutely eBPF plays a significant role to collect that deeper telemetry at runtime, deeper security, deeper protection, you name it. And the other bit, Nick, that we were speaking about on top of on eBPF earlier was essentially about eBPF LSM hooks. So not only you can trace now with eBPF, you can also have these Linux security module hooks, really, which you can, using which you can define process level, pod level policies, and you can actually inline mitigate stuff, right? We use some of that in our commercial product, but idea essentially is to be able to say things like this: hey, I know I have seen an attack path. I see a malicious HTTP request is coming in. After that, I also see there is a file system change and an attempt to make an outbound call to, let's say, CryptoMiner or a command and control server. With this eBPF LSM hooks, you can actually say that I have seen 4 or 5 malicious things now. I can come in and drop that socket connection. As this whole attack is evolving, really, right? So absolutely, not only for tracing, but also for
at the pod level, which is so important, right? That's uncomparable to other observational capabilities.
Absolutely.
All right. So I know we're over time now, so you get each of you get 10 seconds in one sentence. No, actually, let's do this. Forget 10 seconds. In one sentence, if you were to leave our listeners, and the fewer words, the better, leave our listeners with salient advice on improving your Kubernetes program, what would it be?
Nick, you're already 5 seconds in.
I was waiting to get prompted, and I had ChatGPT up. I was going to ask ChatGPT what they're going to say. All right. Yeah. Let me take 15 seconds, Iman. I'll owe you 5 on the backside. Be intentional about what you start with, and be intentional about how you iterate on the journey of Kubernetes security and runtime observability. Be intentional.
Sandeep?
Absolutely. I mean, what I'm saying is going to sound a lot like what Nick just mentioned. Get the basics right. There are no alternatives to that. I mean, you have to do everything that we discussed to ensure that you have all of the checks and balances in place. Start as early as you can in CI/CD. Do not ignore runtime. You must have that. I think if you do this right, and intentionally, as Nick mentioned, I think you'll have a fairly strong Kubernetes detection response program.
Awesome. And I'll probably just add, it's all on you. So therefore, you must be resourceful. So use vendors where you can, but remember that you are the champion for securing your Kubernetes deployments.
Watch the entire webinar at deepfence.io/resources.